Hi students, have a nice day. In this section we are going to discuss about the organic reaction mechanism. What is a mechanism? Mechanism means the path in which the reaction takes place. As we know that a chemical reaction is a formation of new bonds and breakdown of the old bonds. A chemical reaction, generally a chemical reaction is breakdown of the old bond and the formation of a new bonds. That is usually a chemical reaction. So how a reaction is occur, how a reaction takes place. So these things described by organic reaction mechanism. So simply reaction mechanism is the path in which the reaction takes place. It involves the breakdown or cleavage of a bond, the energetics of the bond cleavage, that means the bond enthalpy. When a new bond is formed, you know that energy is released. And the rate of the reaction, the speed of the reactions. So all these things comes under the reaction mechanism. Once again, a reaction mechanism describes the cleavage of bond, the formation of bond, that means the reactants transform into the product side, the enthalpy change, the energies takes place in the bond transformation, a rate of the reaction, order of the reaction, molecularity of the reaction, all these things we explain in the reaction mechanism. By knowing the reaction mechanism, the reactivity of organic molecule can be predicted. So the reactivity of organic molecules is predicted by the reaction mechanism. Also, we have to plan the synthesis of these products. Okay, how the reactant is converted into product. So by knowing the mechanism, we can plan to make the product profitably. So in organic reaction, some important terms we are used. One is substrate molecule. Another is attacking reagent, intermediate, product and byproduct. So what is substrate? A substrate provides carbon for reaction. Simply a substrate is the molecule or the substance or the compound which provide carbon in the case of organic molecule. So substrate is react with the attacking molecule or attacking reagent or attacking molecule. An intermediate is formed. Before making the product, an intermediate is formed. Intermediate is formed. That intermediate decomposes, gives products. Also it gives byproducts. Okay, so intermediate decomposes, gives product and byproducts. So what is substrate? The molecule which supplies carbon. Okay, the molecules which supplies carbon is called a substrate. And the incoming or the attacking molecule is called attacking reagent. Sometimes the substrate as well as attacking molecule contains carbon atom. So in such a situation, we take arbitrarily one is substrate, the other will be reacting molecule or attacking molecule. Okay, are you clear? In some cases, the substrate is containing carbon atom, also the attacking reagent having carbon atom. In such a situation, we arbitrarily taken one of the substance, one of the compound is substrate and the other will be attacking reagent. Okay, this is an introduction about the reaction mechanism. As we know that a reaction mechanism which tells the path in which the reaction takes place. So how the bond is cleaved, or how a bond is dissociated, a bond enthalpy, etc. are discussed as follows. So for that we can discuss a fission of a covalent bond. Fission. What is a fission? The destruction, the cleavage. Okay, I think you heard about fission bomb and fusion bombs. Fission bomb, the heavier nucleus disintegrate into smaller nucleus. In fusion bomb, smaller nucleus fused into a heavier nucleus. So here we are going to discuss about the fission of a covalent bond. The fission of a covalent bond are of two types. One is heterolytic fission and the other is homolytic fission. Okay, heterolytic fission and homolytic fission of a covalent bond. Okay, first we take homolytic fission. Okay, homolytic fission. First, fission of a bond. Fission of a bond. First one is homolytic fission. Homolytic fission. What is homo? Same. As we know that a covalent bond is formed by mutual sharing of electrons. So a bond is between A and B. Okay, a bond is between A and B. A has one electron, B has one electron. That electrons are mutually shared. And when this bond is cleaved or a fission takes place, by taking this electron, the electron of A is taken by the A itself. And this electron is taken by B atom. Okay. And is represented by a curved one head arrow. A curved one head arrow, or it is called a fish hook. Okay, fish hook. What happens? A has its electron plus B has its electron. So how a bond is cleaved? A bond is cleaved by taking, each fragment takes their own electron. Okay, each fragment takes the electron. And an unshared electron is in the species. Okay, unshared electron in the species. So such a species are called free radicals. Free radicals. So what are free radicals? Free radicals contains unshared electron. Okay, once again, a bond is cleaved by taking each electron by each fragment. Okay, two electrons in the covalent bond, each electron is taken by the two fragments. The species which contains unshared electron. Okay, unshared electron. That's why we can say that free radicals. Free radicals are highly unstable. And these free radicals are, that's why, more reactive. Okay, free radicals are unstable and that's why these free radicals are more reactive. Okay, let's take one organic molecule. CH3X. Okay, CH3X. X means halogen or any atom. Usually X denoted by halogens. When it is heated or in the presence of UV light, this bond is cleaved by this X atom takes its electron and this methyl group takes its electron. So what happens? CH3, the carbon having one free electron, plus X, a free electron. So this is methyl free radical. Methyl free radical. What is X? If it is chlorine, chlorine free radical. If it is a bromine, bromine free radical, like that. Okay. So methyl free radical. Are you clear? Then another example. CH3, CH2X. The bond is a homolytic fission. Homolytic fission. So here also homolytic fission takes place. What happens? The electron is taken by this carbon atom and halogen takes its electron. So we get CH3, CH2 free radical. CH3, CH2 free radical plus X free radical. And this is ethyl free radical. Ethyl free radical. Okay. And remember that this carbon atom is a primary carbon. Why? Primary carbon atoms are carbon which bonded to one carbon or no carbon. So this methyl group is not linked to the any other carbon atom, so it is a primary carbon. And what about this carbon? This carbon is also primary. This is primary, this one is also primary. So methyl free radical and ethyl free radicals are primary free radicals. Similarly, isopropyl free radicals, tertiary butyl free radicals are there. Okay. So by changing the alkyl group, if we have different alkyl groups, we get different free radicals. Okay. And the stability order of this free radical is primary is less than that of secondary is less than that of tertiary. This is because of two effects, inductive effect and hyperconjugation. We will discuss later. Okay. Now you just understand that the stability order of free radicals. Okay, the stability order of free radicals are primary free radicals are less stable. CH3 free radical is less stable than CH3. CH2 free radical is less stable than CH3. CH free radical CH. This is isopropyl free radicals. Then this is less stable than tertiary butyl free radicals. Okay, tertiary butyl free radicals. Generally we can write that primary free radical is less stable than secondary free radical is less stable than tertiary. And remember that this is represented by CH3 twice CH free radical, and this tertiary butyl free radical is represented by CH3 3 times C free radical. Okay, CH3, CH3, CH3. That means 3 CH3 groups are attached to the same carbon atom. So this is one of the representation and is condensed by, this is the condensed formula CH3 thrice C free radical. Then the stability is due to inductive effect and hyperconjugation. Okay, we will discuss these two effects later. Then next we discuss about the hybridization of this free radical carbon atom. The hybridization of free radical carbon atom is of two types. One is sp2 hybridization. One is sp2 hybridization. And the other is sp3 hybridization. Okay. When it adopts sp2 hybridization, thus carbon atom, carbon atom, 3 hydrogen or 3 atom like this, and one unhybridized orbital contains a free electrons. sp2 hybridization. As you know that sp2 hybridization, the carbon atom is trigonal planar. Trigonal planar. When it adopts sp3 hybridization, the carbon with a tetrahedral shape, and one of the hybridized orbital which contains free electrons. Understand that? This is sp3 hybridization. In sp3 hybridization, 3 hydrogen atoms and one sp3 hybridized orbital contains free electron. So 2 hybridization depends upon the nature of the carbon atom. That means when it requires sp2 hybridization for bonding, it adopts sp2 hybridization, and if it requires sp3 hybridization, it adopts sp3 hybridization. So this is about the homolytic fission, that is the free radical formation. So a homolytic fission of a covalent bond leads to the free radicals. What are free radicals? Free radicals which contains unshared electron. Unshared electron having or unshared electron present in the species or an atom is called free radicals. And free radicals are highly reactive because it don't have shared electron, or it do not accomplish the octet. And the stability order, you remember that primary free radicals are less stable than, these two are primary free radicals, less stable than secondary. This free radical is secondary because 2 are the carbon atoms. This free radical is tertiary. So the order should you keep it in your mind. Why this order? The answer is due to inductive effect and hyperconjugation. Yes. Then we move to the heterolytic fission. Heterolytic fission. What is heterolytic fission? In heterolytic fission, the bond is cleaved by taking the shared electron by one atom. The shared electron by one atom. Let's take one example. Heterolytic fission. Heterolytic fission. We take A and B. 2 electron is shared by A and B. When this bond is cleaved, that pair of electron is taken by atom B. So A has a positive charge and B has a negative charge. Why? A loses its electron and B gains that electron. So B has a lone pair, unshared lone pair. In free radical, one unshared electron. So here a lone pair is with a negative. Let's take one example. CH3 Cl. CH3 Cl. When this bond is cleaved, the chlorine takes the bonded electrons pair and it becomes CH3 plus Cl minus. Okay, that is Cl atom get the electron. Cl minus. Another example, CH3, CH2, Cl, or you take Br, that gives CH3, CH2 plus Cl minus. And a positively charged carbon atom is called a carbocation or carbonium ion. As earlier it is carbonium ion, now we are usually using carbocation. So, positive charged carbon is called a carbocation or carbonium ion. Okay, carbonium ion. And the stability order of this is a primary, this carbon also is primary. So this is primary carbocation, this is primary carbocation. And the stability order of carbocation is CH3 plus less stable than CH3, CH2 plus less stable than CH3 twice CH plus. This is a secondary carbocation. These two are primary carbocation. Okay, why this is a secondary carbocation? The carbon which is linked to two other carbon atom. That's why it is secondary carbon. Then next is CH3 3 times C plus. This carbon is a tertiary carbocation. So why carbocation is formed? The electron of carbon is taken away by the other atom. Okay, so a positively charged carbon species is formed and therefore it is called a carbocation or carbonium ion. Okay, as earlier it used a carbonium ion. Now we are usually using carbocation. Okay, and the stability order, you remember that primary, secondary, tertiary are same as free radical. And the stability is explained by inductive effect and hyperconjugation. Okay, same factor, inductive effect and hyperconjugation. Okay, we will discuss later. And next we discuss the hybridization and the shape of the carbocation. Hybridization and the shape of the carbocation. Hope you understand all these things. Once again I explain. A and B, both atoms share a pair of electrons. That's why it is a covalent bond. By the cleavage of this bond, A plus and B minus is formed. Okay, and remember that another possibility is there. When AB, the A takes the pair of electron and it becomes A minus plus B plus. Another possibility, if A is more electronegative atom, the electron in pair taken by the A atom. If B is more electronegative atom, the B taken the pair of electron. Okay, so this is a possibility and usually we are writing by this method. So here you look at that CH3Cl. Cl is more electronegative, chlorine is more electronegative. So CH3Cl, the Cl is taken the pair of electron and Cl become negative, carbon become positive. Okay, a positive charge on the carbon atom and a negative charge on the chlorine atom. And that's why carbocation is formed. This is anion. Okay, chloride ion. Okay, then hybridization of this carbocation. It is only one type of hybridization, sp2. sp2 with a positive charge. So carbon atom, 3 bond, hydrogen, 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 a positive charge with an empty orbital. Okay, sp2 hybridization, and the shape is trigonal planar. Okay, trigonal planar. You remember that. Okay, this is the representation of CH3 plus. And one more thing, you don't put the positive charge on the hydrogen atom. That's wrong. The positive charge is on the carbon atom. Okay, positive charge on the carbon atom. Then how an ethyl carbocation is represented? CH3, CH2 plus. So one of the hydrogen is replaced by CH3 group. It is ethyl carbocation. So generally you study that carbocation, the hybridization is sp2 and the shape is trigonal planar. Okay. Then another type of heterolytic fission, the carbon gets negative charge. That is carbanion. Now we just finished carbocation. Okay, positive charge on the carbon atom. Another possibility, CH3Z. Is an atom or group. Okay, group of atoms. Then here what happens, the methyl group or the alkyl group takes the bonded electrons, bonded pair of electrons. So what happens, CH3, a minus charge, a pair of electron on the carbon atom, and the other group Z plus, a cation. And this is called carbanion. So it is a methyl group. We can say that it is methyl carbanion. Methyl carbanion. When you take a CH3, CH2, okay, CH3, CH2, Z group to the carbon atom, we get CH3, CH2 minus. Okay, the carbon atom with a negative charge. Negative charge and the Z is positive. So this is ethyl carbanion. As similar in the previous case, methyl carbocation, ethyl carbocation. And here the stability is in the reverse order. Okay. The stability of the primary carbanion is greater than secondary carbocation is greater than tertiary. The reason is same. It is due to inductive effect. Okay, it is due to inductive effect. Then the hybridization. The hybridization of the carbanion is sp3. So carbon, 3 hydrogen and with 1 extra electron. That's why the molecule is negative. Or not the molecule, the species is negative. So hybridization is sp3 hybridization with a tetrahedral geometry. Or in sometimes it is referred as pyramidal shape. So tetrahedral shape. Tetrahedral shape. Okay, when this bond pair, lone pair repulsion, it adopts the pyramidal shape. Okay, so sp3 hybridization and the shape is carbon, 3 hydrogen atom and 1 lone pair. Okay, sp3 hybridized orbital contains 1 lone pair. So the mechanism is very important. So please go through this topic, heterolytic fission and homolytic fission. In future, many reaction mechanisms, free radicals, carbocations, carbanions comes. Okay, then the cations are usually, we can say that electrophiles, and the anions are usually nucleophiles. So these things we will discuss in the next section. Thank you.